Hi everyone, we are finishing sum and difference properties today with general solutions in solving equations. So if you recall, when you're solving a trigonometric equation, there's not just going to be one solution here unless you have a domain restriction. So there's not just one instance where sine of x equals 1/2. When you apply arcsine, there's going to be an infinite number of correct solutions, right? So arcsine of 1/2 is pi over 6, and it's also 5 pi over 6. Right. So remember that these are kind of our base solutions, and then we are going to add 2k pi to this. Alright, so this is what's known as our general solution. Same thing with cosine, so when we apply arc cosine over here, it's a negative root 3 over 2. I know that this is true for, let's see, 5 pi over 6 and 7 pi over 6. And again, I'll just apply my plus or minus 2k pi, where k is an integer. Alright, so I guess we'll specify that as well. So remember, you can do your fancy double bar z. Okay, now for tangent, remember that the period is different. So this is true for 3 pi over 4. And we can just say plus or minus k pi, where k is an integer. Okay, so this is also true for 7 pi over 4, but this k pi takes care of that answer. Okay, now when we are using our sum and difference formula, you just want to match what you're given to a sum and difference formula, then take the inverse, then solve to find your general solutions, then simplify your answer. Okay, so we'll go through an example, a few examples of this. So right off the bat, I see I have sine times cosine minus cosine times sine. So I know this is going to be a sine difference formula. So I have sine of, if I call this a and this b, then I know this is theta minus 40 is equal to root 2 over 2. Okay, so I'm going to do arcsine now. Root 2 over 2, which is going to be pi over 4 and 3 pi over 4. Plus or minus 2k pi, plus or minus 2k pi, where k is an integer. Now, if you'll notice, I still have a 40 over here. Okay, so I'm going to go ahead and move the 40 over at this point. So finally solve for theta. So now my answer is kind of augmented. It's actually a little bit trickier when you have theta divided or multiplied by something, but in this case, since I'm just adding 40, it's not a big deal. It's just pi over 4 plus 40 plus or minus 2k pi, and then 3 pi over 4 plus 40 plus or minus 2k pi, again where k is an integer. Okay, so not a huge deal, that's the simplification part. You could combine these to get like terms, but I'm not going to ask you to do that. Okay. Moving on, I have cosine times cosine and sine times sine, and they're subtracting, so I know that this is going to be a cosine sum formula, where this might be. So I have cosine of x plus pi over 4 is equal to 1/2. Alright, great. So I can apply arc cosine at this point of 1/2, which is going to be pi over 3 and negative pi over 3. Plus or minus 2k pi, plus or minus 2k pi, where k is an integer. Now same thing here, I have this pi over 4 just remaining, so I'm going to go ahead and subtract that now. And I end up with pi over 3 minus pi over 4, plus or minus 2k pi, and negative pi over 3 minus pi over 4 plus or minus 2k pi, where k is an integer. Again, you can get a common denominator and combine these fractions if you want, but I think that this is simplified enough. Okay, moving on down to tangent. So my tangent formula is again its own special formula. So in this case, this is the tangent difference formula, which is written, and it's also already written for you later in the notes, kind of on the last page if you look. So what I can determine from this is my A and this is my B. Okay. And so again, this is tangent difference. So this is just tangent of 3x minus x, which is equal to negative root 3 over 3. I can reduce this on the inside, so just tangent of 2x. And now I can apply arctangent. Okay, so now I see that I have arctangent of negative root 3 over 3. I need to know what that is. So the way that I usually think about this is the same thing as arctangent of negative 1 over root 3. So I see that if this is sine over cosine, I see that cosine is root 3 over 2 and sine is 1/2. Okay, just the divided by 2 part canceled out. So this is going to be an over 6 angle, a pi over 6 angle, or a 30-degree angle. Some factor of that. And so because this is negative, I know that if it's over 6, it has to be 5 pi over 6, or it has to be 11 pi over 6. Okay, so I'll write 5 pi over 6 plus or minus k pi, where k is an integer. Okay, now I notice that I still have a 2x over here, so I'm going to divide everything by 2x. Sorry, by 2. Okay, and that actually affects every part of this answer here. It doesn't affect this right here. The k is an integer, that doesn't change, but it does change my entire statement. So this will now become 5 pi over 12 plus or minus k pi over 2. Okay, so now every 1/2 pi increment, I will have a solution. Okay, so that's the tricky part. If your x or your theta or whatever variable over here is multiplied or divided by a number, a scalar, then that does affect the increments at which you receive a solution. Okay, so that's the only thing you have to keep in mind, but otherwise it's not that big a deal. It's just why I would recommend you write everything out starting at this step. Alright, that is it for these notes. If you have any questions, let me know. Your homework is below and there's a review after that, and I will see y'all later.